Welcome everyone to this explainer. Okay, let's dive right in and explore the absolute technical backbone of modern industry. Whether you're an engineering student, an electrician, a maintenance tech, or honestly just someone fascinated by how the modern world actually gets built, you are in the exact right place. Today, we're taking a deep dive into factory automation and uncovering the incredible anatomy of a smart factory.
I want you to think about this question for a second. Picture a massive manufacturing facility at 3 in the morning. The lights on the production floor might actually be completely off, but the machines, they're humming. How in the world do these modern factories produce thousands of items, totally flawlessly, 24 hours a day, 7 days a week with literally zero human intervention? It's kind of a mystery of perfectly running, lightning-fast engineering. Well, today, we're going to solve that mystery together.
So here is our roadmap for today. First, what is automation? Then, how the system works, key technology components, benefits and applications, future and careers, and we'll wrap up with Devi Automation Solutions. All right, section 1. What actually is automation?
To really wrap our heads around this, let's contrast a traditional manual factory with an automated smart factory. Manual factories rely entirely on human muscle and coordination. And let's be real, that inherently means they're slower and super prone to errors. We're humans. We get tired, we make mistakes. Now, contrast that with the automated smart factory. We are talking about high-speed, flawless execution. It's this massive shift from heavy, tiring manual labor to a completely synchronized, intelligent system where machines step in to handle all those repetitive, dangerous, or super high-precision tasks.
Moving right along to section 2, how this system works. Let's trace what we call the signal journey and see how this all builds step by step. Imagine a product, say an empty bottle, moving down a conveyor belt. Step 1, our sensors detect it. That sensor immediately fires a digital signal to step 2, the PLC controller. The PLC processes this logic in a fraction of a second and decides, okay, the bottle is here, time to fill it. Step 3, that data goes to the HMI or SCADA system, letting human operators monitor the whole thing. Step 4, the PLC shoots a command down to the VFD or actuator, which physically opens a valve to fill the bottle. And step 5, this loop just repeats endlessly, giving us continuous, high-quality operation. And guys, this whole process happens in milliseconds. Section 3, key technology components. Let's break down the actual parts. First up is the Programmable Logic Controller, or PLC. Honestly, the easiest way to understand this is to think of it as the brain of the factory. Just like your brain takes in info from your senses, makes a split-second decision, and tells your muscles to move, the PLC handles real-time logic, controls the machines, and processes all the inputs and outputs. Without this brain, the factory simply cannot think. Next, we have HMI and SCADA. If the PLC is the brain, these guys are the central nervous system's dashboard. HMI stands for Human-Machine Interface. It's the literal screen where an operator interacts with the machine. SCADA goes even bigger. It's the overarching software allowing for remote plant monitoring, managing alarms, logging data, and pulling historical reports. It basically gives us a clear window right into the mind of the factory. And now for the muscles, the VFD, which is short for Variable Frequency Drive, and the motor control systems. Your brain can think all at once, right? But without muscles, nothing is moving. VFDs are absolutely crucial because they allow for incredibly precise speed control of the motors. So instead of a conveyor belt aggressively jerking to a start, a VFD lets it ease in with a soft start and a soft stop. That drastically cuts down on mechanical wear and tear, and it results in massive energy savings. Rounding out our anatomy lesson, we have the eyes and the skin of the factory. Proximity, photoelectric, temperature, and pressure sensors handle all the real-time detection and process monitoring. Then you have vision cameras acting as the ultimate quality inspectors. They spot tiny defects a human eye would totally miss. And finally, the hands, pick-and-place robots, welding robots, and painting robots that physically manipulate the products for completely automated assembly. Which brings us to section 4, benefits and applications. Why go through all this trouble? Well, the payoffs are huge. The crucial point here is that by taking human error out of the equation, factories instantly hit higher production rates and flawless quality. And continuous 24/7 production isn't just about speed. It actually makes the workplace way safer and saves a ton of energy. Plus, with predictive maintenance, the system can actually warn you that a part is going to break before it even happens. That translates to significantly lower maintenance costs down the line. And this tech is literally everywhere, scaling across completely different sectors. In the automobile and textile industries, it's driving high-speed assembly and manufacturing. In food processing and pharma, automation guarantees perfectly hygienic, untouched packaging, which is vital. It even scales all the way up to heavy-duty environments like cement and steel, while intelligently monitoring massive warehouses and water treatment plants. It's just everywhere. Section 5. Future and Careers. Let's talk about where this is heading. We are right in the thick of what's known as Industry 4.0. The smart factory is constantly evolving. It's way beyond just automated mechanics now. We are integrating artificial intelligence, cloud monitoring, and machine learning. We're seeing the explosion of IIoT, that's the Industrial Internet of Things, and digital twins. A digital twin is where a virtual replica of a physical factory is used to simulate and predict failures before they happen in the real world using edge computing. I mean, it is straight up sci-fi stuff, but it's happening today. Because of this massive technological leap, career paths in this space are absolutely booming. Whether you want to get hands-on with the hardware as a PLC programmer or a robotics engineer, or you want to push the software boundaries as a SCADA, industrial IoT, or AI automation engineer, these skills are quite literally a golden ticket. The industry is desperately searching for people who understand how to build and maintain these systems. Finally, Section 6, Devi Automation Solutions. If you're looking to get involved, Devi Automation Solutions is a total powerhouse. They provide comprehensive services across industrial automation, PLC programming, HMI development, and SCADA systems. But they don't stop at the basics. They're actively pushing into the future with AI, IIoT, smart agriculture, and solar energy solutions. They even provide technical training and run engineering projects. Their motto really hits the nail on the head: smart technology, powerful solutions, better tomorrow. If this explainer sparked your interest, absolutely make sure to like, subscribe, and reach out to them to learn more. Before we wrap up, I want to leave you with one final provocative thought to chew on. As these smart systems become the new normal, taking over everything from simple assembly lines to highly complex AI-driven logic, what will your role be in the smart factory that rules tomorrow's world? The Industrial Revolution isn't history. It's happening right now in real time. I hope this explainer gave you a really clear look into how the whole shebang works. Keep learning, stay curious, and we'll see you next time.